u substitution is going to be what undoes the chain rule. Just to kind of give you guys a little review. If I was going to take the derivative of x squared plus 4 to the third, so just kind of review. Do you guys remember when we had something to an exponent raised to your derivative?
Pull it to the front.
Yep.
Multiply by the derivative of the inside.
Good job. So this, yep, and we kept this part the same. X squared plus 4. What happened to your 3?
2.
Became a 2. Now, part of the chain rule, the inside stayed the same. Then you have to take it and multiply it by what?
2x.
Good, the derivative of the inside, which is 2x. So together, this would become 6x, x squared plus 4 all squared. And that was what the derivative was. Now, what we're going to do today, this idea of u substitution is going to be undoing the chain rule. So it would be like undoing this to get your original. Like the fancy expression for how u substitution is written in your book looks something like this. F prime g of x. We're not really going to use this. It's kind of worthless fancy stuff. I know, it looks crazy. This part here is the composition. Do you guys remember like f of g of x, g of f of x?
This is
Right.
prime.
Right. So this is like the composition of g of x going into the derivative of f times the derivative of g. Like it's kind of like what you guys did up here, right? Where if you took the derivative, right, this part stayed the same, then you did times the derivative of the outside part. Right? So it's saying that if you took the integration of the chain rule, you're going to get this, f of g of x plus c. Right? Now this kind of, I mean, is what it is. It's like a fancy formula, right? We're not really going to be using that. Because I don't want you guys, it's really difficult to be kind of like figuring out the derivative of each part, then doing a composition. That's not. So we're going to make things a lot easier by doing the idea of something called u substitution. Most books and most colleges use the idea of u substitution. They might call it just like a substitution, but most of them always say u substitution. So first part about this, I'm going to make example 1 of some steps for you guys. Here's some of the other steps. First thing we always want to do, if something looks really tough, we want to rewrite it. Like if you guys have something that's a radical, we rewrite it. Right, so rewrite if you need to. Step 2, and what we're going to do is identify the tougher part as u. Okay, so we're going to identify u. Usually it's like the thing that looks tougher, or like what's inside an exponent. So in here, what part do you guys think looks tougher? This x squared plus 2 or the 2x? X squared plus 2. Good. And this, yeah, this is like inside an exponent. That happens quite a bit. That's always what you want to let u equal. So here, we're going to say, let u equal x squared plus 2. You don't need a parentheses part. If you want to put it in there, you can, but not the cubic. No, not the cubic. You're just going to take like the inside part. Okay. Now the third
So you're going to have u cubed times 2x.
All right. This is like a lot of stuff. Okay. So we're going to take d dx of u. Do you guys know what that means? D dx. Take the derivative of
with
u.
respect to x.
Take the derivative of u with respect to x. Good job, Kyle. Okay. So now, if I'm gonna like take the derivative of u, but with respect to x, this is gonna become du. What would the derivative be here? 2x. Good job. Okay, good. Okay, you're gonna start noticing pieces should look like, you should be able to look at the green part and see the parts in the blue, kind of like somewhere in the green section. Okay. Yeah. Right. So, and then we're gonna do this probably for like 5 days, right? This is like long, and it's long. Okay. So then we're gonna look for a pattern. Okay, what I mean by pattern is just that you guys should recognize parts of the blue stuff that's found in your original problem. Right. Now, step 5 is important. Okay. If there's extra info, you'll see what I mean by this in a second. You need to make a correction. Right, then 6 is going to be integrate. Right, so we're going to integrate u, and then sub. Integrate u. Oh, it's going to go down. Right, and 7, we're going to sub back in for u. And the last one is remember your plus b. So you guys will, these are just going to be the steps like in general, right? We're not going to start with like the super hard ones where we need lots of corrections, but just so you guys kind of get an idea of what's going on. Let me know when I can look at the problem now. We won't have to do steps every single time now, right? These will just kind of cover it for the week. Another 8 right down. Okay. So we had to choose which part we wanted to let be u, right? The tougher one, and then we want to take the derivative. Now, we want to look for a pattern. Do you guys see parts of like the du found up at the top?
Yeah.
Yeah, so this is good. See how you guys have that right there? It's found there. Okay, so that means that we don't have to do a correction. If everything's there, we're in good shape. So all we're going to do is we're going to take the u part, right, and integrate u. So it's going to look like this. We're going to integrate u, and we have our little cubed, u I should say. So see how like the du would be like replacing this part? That's what du is to us, right? The u is this part, and we still have our cubic. So what we're doing is we're just kind of rewriting everything, but now it's all in terms of u, so it's easier. How would you guys integrate u cubed?
Make it u to the 4th over 4.
Awesome. Good. Plus c, right? Now, what we're going to do at the end is we don't want u there. We're going to sub back in what we let u be. Think about u like a placeholder. We're just going to let it be u, so we don't have to let it be all this crazy stuff till the end once we're done. So now we're going to take what u was, this x squared plus 2, and we're going to put it back in for the u.
All over 4.
Yep. Plus c, you're done. That's it.
That makes perfect sense. But why can't you just?
Well, they're not all like this.
That's what I was gonna say. Is that why you went so far and depth with it?
Yes, it's going to be tougher. So let's just do another easy one to make sure we're kind of like seeing the matching parts, and we'll talk about maybe like what we have to do if there's a correction. Oh, actually, you know what, too? Let me show you guys how you would check this real quick. This might make sense. Okay. If you wanted to check and make sure you did your u substitution right, u substitution and chain rule undo each other. So if I took the chain rule of this, and you guys tried to take the derivative to check it, your 4 would be in the front. Okay, we keep our inside part the same. Okay. Then we'd have to times it by the derivative of the inside part, which would be 2x. Our 4's would cancel, so then we'd have x squared plus 2 all cubed times 2x. And is that what we did in the beginning? Yeah. It's like a constant. Or if you trying to think how you can say this. If you wanted to like include, well, technically it's not really with the.
Are we gonna find the plus C? Because I don't remember how to do that.
No, not yet. Not yet. We have to do the plus C because you're not. It's not a definite integral, right? Indefinite. We don't know what you're evaluating right now, so that's why we do the plus C. Right? If you had numbers and we subbed in, we wouldn't have to do that. All right, let's do another one. I kind of jumped right into something tougher, but okay. All right, let's try example 2. All right. So that's me. Yeah.
Okay, so we're doing this on our own?
Yeah. Let's see if you guys can figure out what is U. Yeah, right for you got it. Good job. Great. So we say let U equal 3x plus 4. Okay, now we have to figure out what du is. Good. 3. Perfect. Okay. All right. So let's find. Do you guys have a pattern? Does it match and look good?
Yeah.
Yes. I should have put dx on here too. Sorry. You're taking the derivatives, okay. So yeah, we have everything. Yeah, you can find it right in there. Okay. When that matches up, things are nice. Okay, we don't do any extra steps. So then you're just going to integrate in respect to u. So you're going to take your u to the 5th, okay, du, because we have our 3dx. 3dx. We are in good shape. Well, when you kind of go through, you have to integrate now, Kelly.
Oh, now we're going to integrate.
Yep, now you're going to integrate u. So go ahead and integrate with that with me. Yeah. Yeah. So we should have u over u to the 6 over 6. Okay. Then plus c. Okay. Make sure you remember sub back in. Right. So our u was 3x plus 4. Just put your 3x plus 4 to the 6 over 6. Carolyn, I know you were talking about like a common denominator or something. What you were saying? I know you could just leave it like that. Because technically you have to do exponent first before. Like it would kind of change with the bottom ones. You can't just put it underneath both parts with it down. Okay. So these guys are very, very, very general.
And what is that called?
This?
No, your answer. What is it? Du? Is it du dx?
Well, U substitution is kind of crazy because we start with everything in terms of x. You're still technically integrating x, but you're changing everything to be in form of u, so it's easier to integrate, and then we're changing it back. So you're still doing integration with respect to x.
But do you see how du equals 3 dx?
Yep.
What is 3x plus 4 to 6 over 6 plus c equal?
This is this. That's what that equals when you integrate. Like after you actually do the integration process, this is just like the answer of it. Kyle, eventually we're gonna get things where like, you know, I might give you like a, I don't know, 5 and a 3 here, and we're gonna know how we started. Once you got to this part, well, you wouldn't have had to see anymore. You subbed in the 5, then you subtract what it was when you subbed in the 3. You got like a number, right? We're gonna get there eventually.
Why are we finding that number?
Why?
Yeah, so find the area under the curve.
Yeah, this would just be like a different function. So this would be something like obviously a much more typical function that you guys were dealing with before, where you were dealing with maybe like lines or like polynomials. You know, just a really tougher kind of thing. Okay, so let me show you guys one that we would need correction for. And you guys are always going to want to use substitution where, especially when you have some kind of like a binomial to an exponent. That's like a big kind of always comes up when you use substitution. Yeah, something, right? Okay. Oh, good. All right. So what do you guys let your u be? Square plus 2. Good. And then our forgot u. Let u. Okay. Du would be 2x dx. Now let's look to see our pattern this time. Before, we always had a 2x dx here, right? We have our dx, we have an x, but what are we missing? A 2.
So that means we have to add 2 onto the bottom.
Right. Yeah, Kyle, good job. So since we are missing the things, right, we need to make this like correction step. So what I would do is think about it this way, right? If you want to correct this, it's like saying we need to divide both sides by 2. So what we're really going to be doing is multiplying by 1/2. Right? Because we don't have a 2, so all you guys have is this. You have this x dx. So to figure out what would be left, we have to divide by 2. By doing that, dividing each side by 2, we're going to make our correction of 1/2 of the form.
Multiply 1/2 to n.
Yep. And that's when you like the correction. We'll probably use substitution, honestly, till like vacation.
So
This is like a huge thing.
do you multiply 1/2 by your final answer?
Yeah. Yep. Okay. So now once we kind of start this, right, we're gonna have our 1/2. Yeah.
I'm sorry, it's off topic. Michael wants to know if he can break a fist, or should he go to Thailand?
Go to cyberling. I don't have all the cash.
Why does Michael have 50 at school?
I don't know.
Come on, kid.
That's what he gave me for everything.
Okay, so now for once you guys are here, just integrate like you normally would. Okay, so u cubed over 3. We're going to multiply it by 1/2. So this is going to be like u cubed over 6. Good. Plus c. Okay. And then at the end, we're going to take our u and plug it back in. So x squared plus 2 cubed over 6 plus c. Oh, I'm coming to you guys with some of these. There's some real nasty ones.
The plugging in one. That's the one they don't.
Okay, let me give you guys another one.
Or you mean
No, we're not going to do Bertles
Another
today.
Okay.
Yeah, I think I'm saving Bertles for tomorrow.
Thank you for that.
I like this actually.
There's a
Alright, these next two, I'm going to have you guys try. So, if you guys have a radical, think about what did you guys always do with a radical?
It's 1/2.
Awesome. Because
One
yeah,
third, one
yeah.
third.
1/3 this time. Good job. Yeah, because it's cubic. Yeah.
I don't
Well, you
like
can answer a question. You can break it well.
He didn't ask for a cubic, he asked for a radical.
Great.
U to the fourth isn't about the fourth or the fifth.
Wait, what is this? So 3/2?
Wow.
Wait, what is it?
If you guys need to rewrite, do this first. Are you ready to say got it?
Yes.
It's gonna be 3 minus 4 squared 4 times 2 minus 4 squared 4 thirds over 4.
U is 3 minus 4
What you're doing is you're put the 1 third. What you have to do with the opposite. You have to do the corresponding to the thing. You have to figure out what the opposite is.
Okay. No, here's where we're going.
The 4 thirds.
Oh, what is it?
You're reusing up.
Oh, no.
I did the U and I did the
So
D.
check out,
The
you
U
have
is
the
12
look here. Okay, so this is a nice little thing, no fraction, it's a good thing. So you let your U, and then you break it down.
Yeah, we got
So it's like U should, you guys would do that. You're the one, good, yeah.
You're trying to make this.
Oh man, look at my square. Good, okay. If anybody wants to put it up here, great.
Don't let me do that. I'll make that.
Think of like.
So it's okay. Right, so now what else do you have this matched up? Yeah. So this is good. You're not missing anything, you're from direction, this is good. Now you're gonna take your view.
Yeah, I mean, it's
So when you do your exponent, you know, you add one, yeah.
you didn't kind of use it
Ready, watch.
What are you getting?
Okay, so now, alright, now it's okay now. There you go, okay, so now okay, that's really good. Okay, so then it's actually,
So that's the other one you just keep.
yeah, now you just replace your U.
from everyone I've ever talked to.
Yeah.
You have 1/3.
Yeah, so you just
I'm not excited, but I'm kind of interested.
I never felt that I can do it in my head. Your head is
You're just trying to figure out, what's your answer? Yeah, good, good.
I got this and then I
Okay, plus your estimate with what you want to be Divide by 4/3, it's like 1 by 2.
Oh, wow.
And now, yep, so now take your U was, just plug that in, and then you're good. Plus the yes.
No, I don't know what I'm doing.
What's butt? Is it like butt?
Actually not, you're just missing a 4 under D.
Thanks.
Because when you
Oh,
add
well,
one,
I did 1/3.
right?
oh yeah, because when you add your 1, it's 4/3.
Yeah, I added it.
Like this. You can also leave like a D to the 4/3 at the X.
Well, I just
Yeah.
So I did that.
No, they're both equal. So you can see it like this or correct. So they're good. Good job.
It's so funny. It's like a great charades game, but it's like.
Alright, well, since nobody wants to come up, I think I got to everybody. Did we all get this? She did. Sorry, Court. Next one. Did we all get this?
Yeah.
Did everyone? No, don't.
I'm gonna
I didn't get this, I don't know what.
Okay, and this one's for you guys.
I'd rather make.
Those of you guys who got this, try this one.
And you got this one. I don't like this one. Actually, no, this one's. So.
I'm not giving you guys anything in Steam.
There's no other thing, there's only you. Actually, technically, the other thing is
What? Yeah. Yeah, dude, I'm telling you, my video got my fish.
kind of 5 and 5 on one. I mean,
You?
oh, I didn't see the exit a lot.
Oh, you know what?
Literally nothing.
What's in there?
You're right.
Five at 10.
Actually, Sean is wrong.
Oh, wow. So it's deep. 5X plus 1 more. Plus 2.
Yeah, 1 5 X.
That's what it is.
Oh, you did.
I meant square.
I got it. So far. Yeah. Want me to write this one? Yeah. Oh, there you are. Yeah. Right. Yeah, we're gonna wing it.
This one you guys should have corrections. It's really big.
You seems like you guys are secure about everything.
Cordy, you're wrong.
What? What are they?
Why are you so ugly? Are you big? Oh.
And you can go online and do it, and I go online and I'm like, alright, well, just ask me whether or not I'm May 1st. That's the deadline for most, like, colleges for the enrollment fee, so I'm like, you know what, I'm done.
And then 7 days after that, it's
Okay, you're really close.
They're like, if you're accepting the fee, probably about May 1st.
So you're saying you.
Well, then, I don't know, I was confused when he
I
said
don't know
you're
about it.
down here, but now I can't get, I thought you were going to talk about like,
Oh, no. So, you're just being derivative of how you're doing. So, like,
Yeah, really so.
because it will be fine. Good. Yes. And then, exactly what you're doing. Good, now I'll plug it all back in. This is great. Are you good? Good. Yeah. Great. Now, like for 1 10 and then 10 for, okay, I was just worried. Yeah.
If you put the DU before the UQ,
No one's making you go
like if you
for.
wrote a DU,
Oh, I guess
because
technically no. I mean, it's always multiplied. Usually when you read it though, it's always at the end, so then you know what you're taking the integration to. Yeah, I mean, you could have rewritten this, like,
yeah.
if you want to, you know what I mean? To make it kind of look like a little nicer. Very good.
Didn't show it. I read it last night.
I couldn't read it.
So, how are we gonna get started?
Stop for it. Stop for it. In the credit.
Why is that 40?
Hey, everyone shut up.
Good job, Bert. It was beautiful. Beautiful. Okay, so listen, for your homework tonight, I don't want to give you guys a ton because I want to make sure that they're going to be like semi-okay. So I'm going to give you guys 4 problems.
Let's see.
It's not 11 at all.
Yeah, not bad. I just don't want them to sneak up where you have to solve for an X and we didn't do that yet. Okay. So make sure you guys are careful. Use your notes. There are tons of videos also on